State the domain in interval notation and identify any holes, written as ordered pairs, in the graph of this rational function. The first thing we want to do is take a look at the rational function in factored form. The numerator factors as x plus 6 times x minus 4. The denominator factors as x plus 6 times x minus 6. Okay. In this problem, we can see that there are like factors that reduce to 1. X plus 6 divided by x plus 6 reduces to 1. Now what this really gives us is that there's a hole at whatever makes that 0. In this case, x equals negative 6. So by reducing this, essentially we have changed the rational expression, the rational function, to just x minus 4 over x minus 6, with the caveat that x can now not equal negative 6, or else they're not equal. Okay, where the numerator equals 0 is an x-intercept. So our function, we can see, has an x-intercept at 4. Where the denominator equals 0, in our case at x equals 6, is a vertical asymptote. But that analysis is only after you've reduced any factors of 1 you can find. We're looking for the domain. The domain you'd think is all real numbers. So let's give all real numbers to start off. We know there's a hole at negative 6. So here at negative 6, that value is not in the domain. And at positive 6, we would divide by 0. That value is not in the domain either. So we can get the domain as the 3 intervals left over, specifically from negative infinity to negative 6, soft bracket, don't include the hole, union from negative 6 to 6, soft brackets, don't include the hole or the divide by 0 vertical asymptote, and then union from 6 to infinity. Again, soft brackets because you don't want to divide by 0, and infinities can't be included. So that's the domain. Now the hole, there's one hole, and the x value is negative 6. This is from the factor that reduced. It's not in the domain, but it didn't cause a necessary divide by 0 because that restriction actually reduces out. It's just a hole. How do we find the y value? By plugging the negative 6 into the original function, that would cause a divide by 0 error. We can't do that, but we can plug the negative 6 into the reduced function and get y equals negative 6 minus 4 over the negative 6 minus 6. So the x value of the hole we found right at the very beginning. You plug that into the reduced function to find the y value. We get negative 10 over negative 12, which reduces to 5/6. That's the y value of the hole on this rational function graph. All right, I hope this helps.